This is our logical database design, which is based on our ERD of our previous report. We have the same entities, course, lecturer, grade, and student. We also have an extra entity called registration. This is because in our previous report, student and course have a many-to-many relationship. So we need to break that relationship. And so we created two one-to-many relationship. The entity registration has foreign key registration number from student and course code from course. It also took out registration date, course set, and timetable from course entity. Registration number and course code act as a composite key. So the new relationship is one student can perform many registration, but one registration can be performed by only one student. Next, one registration can enroll one course, but one course can be enrolled in many registration.
For table and records, we place these 17 attributes into one big table. There are repeating groups in the data as each cell has more than one value. They are highlighted in red.
For 1NF, the primary keys are registration number, course code, and lecture ID. I have separated each row only contain one single data, because it what applies for 1NF. And for the timetable column, I have separated it into 3 columns, into day, time start, and time finish. This is because in the previous 1NF, the timetable column contained multiple data. So to 1NF, I have separated them, so the columns only contain one single data.
We have 3 types of functional dependencies in SMPWeb UKM. The first is full functional dependency, second partial functional dependency, and last transitive functional dependency. So first, the full functional dependency in SMPWeb UKM can be represented by this blue line, where the course code with the course set and the registration number of a student can determine the registration date of a course, the lecturer ID, and the grade. Next, we have 3 types of partial functional dependency. The first is represented by this orange line, where the course code and the course set can determine the course title, course level, credit, and the timetable. Next, the second partial functional dependency is represented by this green line, where the course code, course set, and the registration number of a student can determine the registration date of a course, the lecturer ID, lecturer name, and the grade. Last, it is represented by the yellow line, where the registration number of a student can determine the student name, faculty, program, ID card number, address, and phone number. There are 2 transitive functional dependency in SMPWeb UKM. The first would be the program can determine the faculty, and the next is the lecturer ID can determine the lecturer name. Tables that you will obtain when you normalize the first form of table to its second form. You will get the course table, which has the course code, course title, course set, course level, credit day, time start, and time end. Next, the student table, which has the registration number of the student, student's name, faculty, program, ID card number, address, and phone number. Next, the registration table will store the course code, course registration number of the student, and the registration date of a course made by a student. Lastly, you will get a grade table which has the course code, course set, registration number of the student, the grade of a course, the lecturer ID and lecturer name, which key in the grade of a course to a student. Even though we have normalized our table of records from its first normal form to the second normal form and removed all partial dependencies, but still we have transitive dependency in our table. So the way to remove it is to normalize it into the third normal form, where we eliminate all the transitive dependency. We remove the lecturer name that was previously in the grade table and create a lecturer table that has lecturer ID and lecturer name. Same goes to the faculty information that was previously in the student table. We extract it, make a program table, and reference the faculty to the program.
In conclusion, the first step is we need to have a logical database design. So this is the logical database design for SMPWeb. And then from this logical database design, we will do a UNF table. And from this UNF table, we will convert it into 1NF. And then 1NF into 2NF and 2NF into 3NF step by step as we mentioned before, so that we will get a proper and organized data.